Hello friends, welcome to the Embedded Guy. Topic of this video is what is microcontroller. Here we will understand microcontroller by comparing it with the human body. So let us start. First of all, we will understand the human body in electronics way. The most important part of human body is brain. The brain has two most important functions. The first is to store information in memory. Whatever we learn and perceive is stored in our memory. The second function is processing. Here whatever data is stored in the memory is used for processing, to take decisions and control our actions. So, these are the two most basic functions of the brain. Now the second most important organ is heart. The most important function of the heart is flowing of blood throughout the body. Because of this blood flow, the signals flow through our entire body. And because of this flow of signals, our brain is able to work, and other organs are able to communicate with each other. It is a simple thing that, to make the signals flow, our brain, heart and other organs should get connected to each other. And the work of this connection is done by our veins. These veins connect our organs to the heart and brain, which helps in the flow of signals or data. Here the heart, brain and other organs will need energy to do their work. They get energy from its digestive system. Now, if we look at heart, brain, digestive system and veins, these are the basic parts that can keep a human body alive, but still useless for doing any meaningful task. Let's understand the basics parts of microcontroller and relate them by comparing with the human body parts. The most important part of the microcontroller is the ALU arithmetic logical unit, which does the processing of data. And the second most important part is memory. Here we have RAM, ROM, flash, registers as memory. RAM and register are used to help ALU, while processing and ROM and flash memory stores data and program code permanently, just like our memories. So now if we combine the ALU and memory together, then we can call it as microcontroller's brain. The second most important part is the clock. Here the clock is provided as inbuilt or using an external oscillator. The clock is like a square pulse which keeps on shifting from logic 0 to logic 1 and vice versa. Because of this square pulse, data shifting takes place between the ALU and the memory. Also, the ALU is able to do the processing and transmit the data throughout the microcontroller. Just like the heart has a heartbeat in the human body. And because of this heartbeat, signals flow throughout the body. Similarly, here the microcontroller has square clock pulses, because of which data can flow through the entire microcontroller. Hence the clock is called the heart of the microcontroller. Now the parts of the microcontroller like ALU, memory, clock and other parts like peripherals, about which we will talk later. All these are interconnected via data bus, address bus, peripheral bus, and many such different types of buses. Due to these buses, data can be transferred to each other. Similar to veins in the human body. The microcontroller is an electronic device, so we need electricity to power it. Generally, microcontrollers use very less power and operate on very low voltages like 3.3 volts or 5 volts DC. This power needs to be given externally to the microcontroller using battery or AC to DC adapter. So this is the basic comparison. Now, the human body parts which we have understood. A person can be just alive but cannot do any work. Similarly, the parts of the microcontroller that we have understood are the basic parts and we can call it as a very basic microprocessor, but still cannot be called as microcontroller. When we add peripherals to it, then we can call it a microcontroller. Let us understand through an example. If human body needs to move 5 steps forward by avoiding any obstacle, then this body is still not capable to do anything except thinking, as it is only brain and heart. But let's say brain gave command to walk 5 steps forward, then we do not have legs. Who can listen to the command? So, to receive and understand that command, it is very important to have legs. Here these legs are attached as a peripheral, and upon attaching, it will have to be stored in memory that body have these 2 legs available now. Also, we need to attach 2 eyes, so that eyes will be able to see the obstacle and give inputs to brain for processing and giving commands to the legs for moving and stopping. Like this, our body will be capable to do some work only when we will attach peripherals and register it with our brain, so that the brain knows where to transfer signals and commands. The same thing happens in a microcontroller. Let's say we need to read the voltage and show it on display. Here we will need ADC's peripheral, which will be connected to brain of our microcontroller via a peripheral bus. The ADC will sample the analog voltage and convert it into digital binary, and that data will be transferred to our microcontroller's brain, so that ALU can process it and display it. To display the data, if we use a normal LCD screen that can be operated using GPIO, then we need to attach the GPIO peripheral as well. Now, because of ADC peripheral, we can read the voltage data and processing it with brain and display it on the LCD display via GPIO peripheral. There are many such peripherals like SPI, I2C, UART, timers that are attached to the microcontroller during designing phase. Companies design these microcontrollers in different ways for different tasks or applications, and adds peripherals to it accordingly. It is our job to choose specific microcontroller for our application. I hope that with the help of this comparison, you were able to understand the basics of microcontroller. For more such knowledgeable videos, please subscribe us and like our video, so that we can keep working hard for you guys. Thank you.